So now let's try the construction of a Pourbaix diagram for aluminum. So this one is ito yung example natin sa dulo. Example 4, or the practice problem here. To construct the EL4B diagram, 4 species were considered: EL, EL3 plus, EL2O3, and ELO2 minus. Assume that the ion concentration is 10 to the negative 3 molars. And what we're looking for is we should get a Pourbaix diagram that looks something like this. So ganito dapat yung makuha natin from our process. But now let's go to this one. Yes. Share. Okay. So to construct our Pourbaix diagram, again, we follow similar steps to our PP diagram, which are some modifications. So for the Pourbaix diagram construction, we first identify the species that we are concerned with. So in this case, we are concerned with, okay, we are concerned with, excuse me, AL, we're concerned with EL, EL3 plus, AL2O3, and EL2 minus. So we're concerned with 4 different species. So for 4 species, we would have 4 times 4 minus 1 over 2 couples. This will become 6 couples. So we have 6 permutations. And to aid us in our solution, we just have the values of H2O and H plus here. So assumption natin is that the concentration of our ions for aluminum and ALO2 minus will be 10 to the negative 3 molars, or 0.001 molar, or 1 millimolar. Yes. So again, we have 6 different couples. 1, 2, 3, 4, 5, 6. So we get the chemical reactions for this one. If it is an electrochemical reaction, we express this in terms of a reduction reaction. Otherwise, we just express it as a chemical reaction. So for example, for this one, EL to EL3 plus, we express this as a reduction reaction. So ang reduction, Leora, Geroa, gain electrons reduction. Gain electrons reduction. So mangyari, Al 3 plus 3 electron minus to form Al. So sa reduction reaction natin, nasa kaliwa si electron. Kasi kinakain siya ng ating other reactant to form yung ating product. Na-reduce yung na-reduce yung oxidation state nito. So that is for Al3 plus to form Al. So we can do the same, similar for the others. So let's try siguro itong Al to AlO2 minus. So for this one, we have AlO2 minus to form Al. First, we balance this out first. So we balance this by using our, minds. Let's say put our minds into balancing this one. So AlO2 minus Al, kulang siya ng oxygen. So we add oxygen in the form of water. Here. Plus dalawang H2O, 2H2O. Then we have kulang tayo ng hydrogen on the other side. We add 1, 2, dalawa, 2 times 2, 4. 4 hydrogen ions. Now we need to balance the charge of the products in the reactant side. Charge nito is plus 3, charge nito is 0. So we can balance that by adding electrons into our system. We add 3 electrons plus 3 electron minus para negative 3 charge. Magiging equal sila to 0, left and right, left and right. So this will be the balanced chemical reaction for this one. So we can do that for every one of our every one of our couples here, and we'll get the balanced chemical reactions will be ganito. See? So yeah. So if you're taking down notes, I'll siguro give, well, you can screenshot naman this. I'll give you some time to screenshot it. Okay. So now that we have the balanced chemical reactions, we now determine the delta G naught and the standard from this. So we determine the delta G naught for each of these reactions, and then we determine the then we determine the standard potential for each of these reactions. So we're in a table, nandito. Yes. So again, delta G naught is just equal to delta G naught product minus delta G naught of the reactants here. Delta G naught is equal to this one. So let's look at one of our reactions. So nasimulan ko na rin naman. Gagamitin ko na yung AlO2 minus. So we have AlO2 minus plus 4H plus 3 electron minus to form Al plus 2H2O. Delta G naught here is products minus reactants. Products mo is Al. Al is 0 plus 2 times H2O. For water, yung ating water has a delta G of negative 237, 141, negative 237, 141, minus our reactants. AlO2 minus is negative 830, 900, plus 4H plus. H plus is actually 0. And plus yung tatlong electron natin. Electrons also have a delta G of 0. So remember, delta G of electrons is 0. So dapat tinuro sa inyo yun sa chem. Then solving for this one, we would get the delta G naught of our AlO2 minus to be 356,618 joules per mole. So we do that for each of our expressions. For each of the ones here, we'll get the delta G as shown dito. So from that one, we can get the standard. So kunyari dito. So we can get now the standard electron, standard potential of these chemical reactions here if they involve, if they are redox reaction or if they are reduction reactions. So in this case, tatlo lang yung pwede natin makuhanan nung electrical potential or nung electrochemical potential since tatlo lang naman yung magkakaroon ng transfer of electrons. 1, 2, and 3. For the other reactions, makita natin there is no transfer of electrons here, here, and here. So hindi natin makakuha tong E naught na ito. So in this case, we have this one number of electrons. We can get yung E naught natin from the delta G naught here. So for this reaction here, E naught, this should be 6. So for this one here, we have this expression. E naught is equal to negative of delta G naught. Delta G naught is 356,618. Negative of the negative, so this will become positive. 356,618 over N. N is the number of electrons involved in the reaction. So in this case, tatlo siya. 3 times Faraday's constant, which is 96,485 or around 96,500 coulombs per mole. Solving for this one, we get E naught is equal to 3 Negative, negative. Sorry. Negative. Negative 356. Sorry, negative pala. So E naught will be equal to negative 1.231. Doing that for each of our reactions that are reduction reactions, we get the following E naught values. This one, and this one. So for the other ones, again, since wala tayong transfer of electrons, this step is not needed to be done. So now that we have that one, we can now use yung E naught na nakuha natin dyan for the Nernst equation. Since for the Pourbaix diagram, the goal of the Pourbaix diagram is to get, the goal of our Pourbaix diagram is to get a graph showing potential versus pH. Electrochemical potential versus pH. Oh, sorry. So to get that, we first make our Nernst equation. So we have the following here. So I just rewritten this one. Then for the Nernst equation, sorry. So for the Nernst equation, the Nernst equation natin has a, sorry. My God, throat is so dry. Yung form ng Nernst equation natin is E is equal to E naught minus 0.0592 over N times log Q. So this is at 298 Kelvin, where Q is your reaction quotient. So we can use that to get yung Nernst equation for this. So it's nakuha natin E naught. We would have, let's say for AL to AL3 plus, or let's just show them, would have the following expressions. So E is equal to E naught, dito E naught, minus 0.0592 over N, the number of electrons being transferred in our reaction. The number of electrons being transferred in our reaction times the logarithm of Q. Q is your reaction quotient. This is similar to your equilibrium constant. This is yung product over reactants natin. So for this one, Al3 plus 3 electron minus to form Al. Product is Al. Al has an activity of 1. Electrons have an activity of 1. So we only have Al3 plus. Activity of Al3 plus, it's an ion. This is just the activity of Al3 plus here. This will become the concentration of Al3 plus. So we do that for each of our expressions. So we go through them one by one. Al to Al2O3 is Al2O3 plus 6H plus 6 electron minus to form 2Al plus 6H2O. E naught is equal to negative 1.504 minus 0.0592. 6, since there are 6 electrons being transferred. Logarithm of products, 2 times Al. 1 raised to 2 is 1. H2O raised to 6, but the activity of this one is 1 since it's a pure substance, over Al2O3 activity, which is 1, 6H plus, activity of H plus raised to 6, plus 6 electron minus, activity of electron is 1. So we do that for each of our expressions, and we'll get the following. This one. For our 3 that produces reduction reactions, we get ito. So for AlO2 minus, we have E is equal to negative 1.231, which is its E naught, minus 0.0592 over 3, logarithm of 1 over AlO2 minus, activity of H plus raised to the 4. Since ito lang yung may concentration, ElO2 minus, H plus raised to the 4. H plus raised to the 4. Electrons has no, activity niyan is 1. Al activity 1, H2O activity 1, ElO2 minus has an activity. So we have this. For the reactions naman that does not have or that are not reduction reactions or does not involve the transfer of electrons, what we use now is yung delta G naught natin. Delta G naught is equal to negative 2.303, or we use this expression. Delta G naught is equal to negative 2.303 RT log Q. So in this case, since wala tayong E, we're using this expression para makahanap tayo ng function with respect to pH. We're looking for the pH in which magkakaroon tayo ng transition. So in this case, we have delta G naught is equal to negative 2.303 times ito, logarithm of Al3 plus raised to 2 over, so ito yung products, reactants natin, Al2O3 is a pure substance, 6H plus, activity of H plus raised to 6. We do that for all of our natitira, ito and ito. And we get these expressions here. 1, 2, and 3. Sorry. So from that one, from these expressions, from the Nernst equations here, our goal is to get E versus pH. We're looking for E as a function of pH, or in the absence of electron transfer, we're also looking for pH is equal to some value. So first, let's look at So let's look for this one. Let's look at this one. E is equal to negative 1.676 minus 0.0592 over 3 times logarithm of 1 over AAL3 plus. Yung E naught natin here is 1.676. We can actually AAL3 plus here. We assume that AL3 plus is a concentration of 0.001. So logarithm of 1 over 0.01, this would become 3. 3 over 3, this is 1. So ang mangyari dito, E will be equal to negative 1.676 minus 0.0592. Or equal siya sa, math is hard, 1.61 something. Let's look at my notes. 1. Sorry. Math is hard. I don't know how to math. 1.735. 1.736 negative. Now let's look at something that has EH plus. So dito, E is equal to negative 1.736. Wala kang variation with pH. We expect this will become a horizontal line. Now let's look at Al, AlO2 minus here. For this one, we have E is equal to negative 1.231 minus 0.0592 times the logarithm of logarithm of 1 over ALO2 minus AH plus raised to the 4. So this will become log of 1 over ALO2 minus plus logarithm of 1 over H plus raised to the 4. So I just used yung products inside the logarithm will become addition or sum. So in this case, we can solve for this one, log of AAL02 minus 4 over 3. This one is just 0.01, 0.001. So this is 0.001. Itong log of 1 over AH plus to the 4, this can be expressed as 4 times log of 1 over AH plus, or this can be expressed as 4 times negative log AH plus. We know that the logarithm, the logarithm of the activity of hydrogen, or the negative of the logarithm of the concentration of hydrogen, this is actually equal to pH. So this one will become 4 pH. So then, yung expression natin for that one, E will then be equal to negative 1.231 minus 0.0592 over 3 times 3 plus 4 pH. Simplifying this one, we would get, so simplifying that one, we would get ito. E is equal to negative 1.291 minus 0.0789 pH. So we can do that again to the other AL2O3. We have E is equal to negative 1.504 minus 0.0592 pH. Now for the other expressions that does not involve hydrogen ions, we can get the pH from this expression. Delta G naught is equal to this quantity, which is equal to negative 5705.8 times the logarithm of AAL3 plus squared over AH plus raised to the 6. We can decompose this such that magkakaroon tayo ng expression for pH. This expression here is equal to 2 log AAL3 plus minus 6 log AH plus, or this one will be equal to plus 6 pH na siya. Okay, this expression is ito. So if we convert this, if we evaluate this, we'll get pH is equal to 3.914. So this will become a vertical line. X is equal to 3.914. And for the other given, we also have pH is equal to 5.64 and pH is equal to 10.81. Vertical lines again. So do you have questions regarding this? Did they have questions? Oh. So Fala, I'll proceed. So this one, this is more of mechanical naman kung how to do this. Once you know the procedure, you should not have any trouble unless nagkamali kayo sa pag-set up ng equations, like what I did kanina before I started this class. Medyo I was nagmamadali. So if you plot all of these lines, 1, 2, 3, 4, 5, 6 lines here, you get itong lines na ito. So we'll get this equilibrium lines. We have E or V, so this is in voltage, and we have pH in the x-axis. So again, to get whether the line or the component will be on the top or on the bottom, we use again yung ating Le Chatelier's principle. or if tinatamad kayo, meron tayong notes dun sa ating modules. But essentially, it just did what the Leschetier's principle there. Ang mangyari is that species that are at the same side of the electron will be above the equilibrium line. So that's from the Leschetier's principle. It has something to do with yung potential, has something to do with gaining energy, electrons. And in that case, if we have, let's say, Al to Al3 plus, Al3 plus 3 electrons to form Al. Al3 plus is at the same side with the electrons. It would be above the equilibrium line. This is Al3 plus, Al3 plus. So mangyari, Al sa baba, Al3 plus sa taas. Or yung na-oxidize, yung nasa taas. At the same vein, for Al2O3, Al yung nasa baba, Al2O3 nasa taas. For AlO2 minus, Al yung nasa baba, AlO2 minus yung nasa taas. Now, for the lines that are vertical, we need to look at its reactions. Gagamitan na natin siya ng Leschetier's principle. So let's look at this line here. Itong line na to is your, from here, Al3 plus to form, sorry, Al2O3. So sa expression natin for this reaction, we have Al2O3 plus 6H plus to form 2Al3 plus 3H2O. So to know whether nasa left side tayo or right side ng line yung ating species, we have to look at this hydrogen here. Kasi yung hydrogen mo, related yan sa concentration, concentration ng hydrogen mo is related to our pH. If we increase the concentration of hydrogen, we're actually moving to a lower pH. Remember, pH of 0, pH less than 7 is acidic, and pH greater than 7 is basic. pH less than 7 is mas konti yung hydrogen ions, pH greater than 7, mas konti yung hydrogen ions. So medyo baliktad siya nakakalito. So mangyari, if we increase yung H plus concentration natin, what would happen is your system will compensate by creating more of the product side. Consuming this, increasing this. So increasing the H plus concentration means going to a lower pH, producing more Al3 plus. So this would mean that Al3 plus would be at this side and Al2O3 would be on the right side. So for these vertical lines, we can just remember that if it is at the same side of the hydrogen ion, it would be to the right. So in this case, this line is Al3 plus and AlO2 minus. AlO2 minus is kasama niya si hydrogen ion. Dito si AlO2 minus. Dito si Al3 plus. And for this one, this is AlO2 minus, Al2O3, AlO2 minus, and Al2O3. Ganito siya. So I'll just rewrite this so it will become better looking, I guess. So we have Al3 plus, Al2O3, Al3 plus, AlO2 minus, and Al2O3, and AlO2 minus. Meanwhile, sa baba natin, this is Al and Al3 plus. This is Al Al2O3. And yung green line natin is AlO2 minus. So to get the stability regions for this expression or for this Pourbaix diagram, again, we just do what we did with the PP diagram. We just assume a stable line that is connected to our triple point. So in this graph, we have 3 triple points, 1, 2, and 3. So for the sake of convenience, I would assume that the stable triple point would be the stable line connected to that triple point will be this one. So I'm assuming that this line here, I'll use my line tool. This line here would be stable. So if that's stable, this one is unstable. This is stable. This is unstable. Tama? This is stable. And this will become unstable. This line is connected to another triple point here. So stable, unstable, stable, not stable, stable, and not stable. So again, to check if our assumptions is correct, we can use yung ating checking method in which we see if the boundaries bounding the stability regions have all the same species. So in this case, this is Al3 plus. So this is Al. I'll use a different color. Let's use my favorite color, yellow. So this is Al. And this line is Al sa baba, Al2O3 sa taas. Al sa baba, Al2O3. It's Al. And this one is Al. So this would become aluminum. Yung sa taas nito is Al3 plus. Sa right nito is Al3 plus. This will become Al3 plus. So dito, we have Al2O3, Al2O3, Al2O3. So this one is Al2O3. And sa right, AlO2 minus and AlO2 minus. So this will become AlO2 minus. So just making this a bit more prettier, our stability regions would look something like this. 1, 2, 3, 4, and 5. Where let's have this one. And oh no. Where we have different painting. Later. Oh. With different stability regions. Here. Project is done. This. So indulge my. And the stability regions would have this Al3 plus, Al2O3, AlO2 minus, and sa baba is aluminum solid. this is E versus pH. So from this diagram, we can see that aluminum ions, Al3 plus ions, are more likely to be formed when your potential is high and your pH is low. AlO2 minus are more likely to be formed when the pH is high and the E is high. Al2O3, the oxide, is when we are in intermediate pHs. And Al, or the base metal, is more likely to be formed if your potential is low.